porque es un repasito, pero si me lo piden, inmediatamente. Bueno, entonces de acá, ¿no? Ok, mira tan bacano como quedó. Qué cool, ¿no? Qué re cool. Sin necesidad de anotarla de nuevo. Si lo perdieron, voy a borrarla, mira. Voy a borrar la función. Ya no tengo nada en las funciones, ¿listo? Entonces voy a estadística, calcular y vamos a calcular una regresión cúbica. Regresión cúbica. Por supuesto, los datos ya están en la calculadora. Lista 1, lista 2. Frecuencia no tiene nada. Y aquí, guardar ecuación de regresión. Presiono el botón de variables. Aquí está. Presiono. Me muevo a Y bars, variables de Y, o sea, hacia la derecha. Tin, ya está. Y ahora selecciono la función. ¿En cuál de las Y's quiero guardar la función? Digamos que en Y1. Oh, pues la podemos guardar en Y2, no sé, en la que quiera. Voy a guardarla esta vez en Y2. ¿Por qué no? La guardamos en Y2. Y ahora calcular. ¡Pah! Inmediatamente aparece la función con los valores, pero si voy al botón Y equal, donde están guardadas las gráficas, las funciones, perdón, ahí está, aparece, mira, en Y2, ahí está, mira, tan bacano, ahí está. ¡Ah! ¡Qué cool! Ya no tengo que escribir nada. Entonces, si presiono automáticamente graph, mira, 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 mira. Mira, tan bacano, mira, mira. Hijo de madre, se escachó un poquito y baja otro poquito. Hijo de puchica, otro poquito para arriba. Y tan bacano, ¿no? Ah, espectacular. Bueno, mis niños, cuéntenme. Voy a hacer una pregunta y me la responden en el chat, ¿listo? Esta regresión, este modelo, o sea, la gráfica rojita, ¿listo? Por supuesto, para ustedes, pues de pronto tiene otro color, ¿no? ¿Es una regresión perfecta o no? En el chat, por favor. Ok, no es perfecta. Gracias, muchachos. Excelente, gracias. Ok, vamos a mirar si fue suerte. O saben, ¿qué tiene que cumplir para que sea perfecta? En el chat, por favor. ¿Qué tiene que cumplir o qué tiene que pasar para que sea una regresión perfecta? ¡Guau, mis niños! Espectacular, qué rico que se acuerden. Qué rico que se acuerden mucho. Ve, yo no sé por qué lo estoy haciendo en español, lo siento. All right, that's beautiful that you guys remember. Thank you. Amazing. Amazing, guys. All right, you guys are correct. What I need for the regression to be perfect is that it passes through every single point. Over here, over here. Look, this point also, the line needs to pass through this point, right? This point is being just touched in one of the corners, but I need to pass right through the middle, right? That is what it means to have a perfect regression, a perfect model. So the perfect is not model. Doesn't matter. We don't have to have a perfect model. This model is really, really good. This is a really good model, right? So again, it doesn't matter that I'm not touching a couple of points. What matters is that it is touching most of the points. So this is a perfect model. All right, okay, all right, let's continue. Let's go back to the questions here. All right, so use a graphing utility to find the cubic function. We have it, right? We have it right here in Y equal. It's right there. We have the function. Beautiful. Let's continue with C. Use the model finding part B. Okay, so this function, we're gonna use this function to do something, right? We're going to predict what? We're going to predict the number of major hurricanes that struck the United States between this time and this time, these 2 years. So between 1961 and 1970. So we're talking about this decade, right? This one, right? Number 5 in X, right? Are you guys following me here or not? All right, so we know, according to the table, the amount of hurricanes are 6, right? This is what happens in the table. So these are the real data. These are the real data. In 1961 to 1970, we had exactly 6 major hurricanes in the United States. Right? All day, they had 6 major hurricanes, right? All right. But if we use the model to predict it, how much are we going to get? How much are we going to get? This is how you do it. All right, guys. This is why we graph it. From here, from the graph, this is how we predict, all right? This is new stuff, guys. So please pay as much attention as you can. All right. From here, we're going to use the calculate option. This is using second and trace. Again, can you see the key? Trace. So do second and trace. If you do that, the calculate menu is going to appear. And all we have to do to predict something is to use the first option, value. Look, we can find a lot of options here. We can calculate a value, we can calculate a zero, a minimum, a maximum, an intercept. All of these, you know them, right? Zeros are the intercepts with the x-axis, right? Maximum and minimums, those are these little curves in here. So here, this is a maximum, and here, this is a minimum, right? So we can calculate all of those. But right now, since we want to predict a value, we want to calculate a value. So right there, you just press enter. And look at this. This is what the calculator is going to ask you. To enter a value of x. This is what the calculator is asking you. Enter a value of x. So once you put a value of x here, the calculator will give you the appropriate value for y. Since we want this decade, 1961 to 1970, we want to write down the value 5, because that is the one for x, 5, right? So we just go ahead and press 5. No, not 45, just 5. I don't know what I did. Let me do it again. Calculate value there, 5, right? And if we press enter, the result, look at that. Look at what the calculator is showing me. All right. X equals 5, right? So when x equals 5, the value y, the result for the function is 6.31. All right. So what that means is that the prediction is that in the United States, between 1961 and 1970, these people should get 6.3 hurricanes. That is what they should get, 6.3. And look at that. They got exactly 6. So it looks like our model is pretty good, right? Because we are really, really close to this value, to this number. All right, cool, beautiful. This is the answer to number C. This is how you predict values, guys. And look at that. All we are doing is using the calculator properly. All right, this is just proper use of calculator. All right, let's jump into question D. Let's jump into question D. And for this, I want all of you to go ahead and read the question. And I'm going to ask one of you to explain us what is the question about. This looks like a scary question, but it is not, all right? It is not. Just go ahead and read it carefully. Okay, I think that's enough time, right? I think all of us read the questions, and it is now the moment for who am I gonna ask? Let's go with Mari. Mari Science or Aleja Science. Can you hear me? Alejo. Mariana Aleja. Aleja. You hear? Aleja. Aleja Sainz. Are you here?
Profe, es que me quitó
Valerie me dice, profe, no le carga el Meet. Ay, se le congeló. Ok, listo, Valerie, gracias. Who else then? All right, let's see. Who else? Who am I gonna ask to help us? You know what, Valerie? Valerie, why don't you help us? Valerie.
Mister, I
Yes,
can help.
Valerie, what? I can what?
yes, teacher.
Thank you, Valerie. Valerie, why don't you tell us, please? You can do it in English or Spanish, all right? Don't worry. Why don't you please tell us what is the question D about?
That people is concerned that the hurricanes are going to increase,
Uh-huh.
but scientists say that it's going a decade or two more.
It's going to
So we
what?
have to use the model.
Okay. A decade or two more. All right, beautiful. Okay, thank you. Valerie, you did it great. Thank you, Valerie. All right, that is the context, right? That is the context right there. Right? People are scared. People think that we're going to have more and more and more hurricanes. But
Teacher,
the scientists think that that's only going to happen for maybe 2 more decades. Give me just 1 second, Danny, please.
okay.
The scientists believe that that is just going to happen for maybe 1 or maybe 2 decades. All right. Okay, Valerie, can you continue with the rest of the question? What do we have to do here?
We have to use the model to predict if that's going to happen.
All right. Thank you, Valerie. So let's do that, guys. Danny, go ahead, please.
Teacher, I think that the solution for this problem is to do the same as the last problem, except that instead of putting 5, we plot a value of 9 as x.
9, and why did you say 9, Danny?
Plot 9, a value of 9 instead of a value of 5.
Yes, Danny, but why? Why did you say 9? Why not
Because
10 or any other number?
what's next. It is what's
all right.
next.
Danny, you know what? You're great. Thank you. Yes, sir. You are correct. Look at these guys, everybody, in case you didn't see it. Look, this is the table, right? So from the table in the data, we can see that the decades are enumerated with values from 1 to 8. So if we want to calculate from 2001 to 2010, well, that is the next decade, right? That is the next decade. Meaning for x, we will have to write down a value of 9. Just like Danny is saying. So we are going to do just that from here. Press again, second trace to do calculate. We're going to calculate a value and we press the value of 9. Enter, and look at that. It looks like people in the United States from 2010, from 2001 to 2010, they should get about 9.7, 9.8 hurricanes. So really close to 10. Really, really, really close to 10. Huh? Here, question B. Use your model to predict the number of hurricanes. Okay, well, the number of hurricanes are going to be at least 9, maybe 10, right? Really close to 10. Huh? Go ahead and write this down in your notebook, guys. Hopefully you're writing down these answers, right? In the notebook. So write this down in the notebook as well, please. Now, let's continue because this is not the only question. Look at this. We have a second question, right? Does your result appear to agree with what these scientists believe? Paso un momentico al español. Quiero ver sus opiniones. Esta respuesta puede ser de múltiples, perdón, esta pregunta puede ser de múltiples respuestas. Así que quiero escucharlos. ¿Creen ustedes, mis niños, de acuerdo a los resultados que tenemos, que los científicos tienen la razón o no? ¿Están de acuerdo con los científicos o no? Ok, pues ¿qué piensan los científicos? Bueno, los científicos piensan que estos cantidades de huracanes son una fluctuación. Y la fluctuación puede durar tal vez 1 o 2 décadas. Eventualmente va a volver a bajar. Esa es la idea de fluctuar. Aquí lo podemos ver, mira, subió y luego bajó. Entonces, contésteme, mis niños. ¿Están de acuerdo con los científicos? ¿Sí o no? En el chat, por favor. Esto no es solo escribir sí o no, ¿no? Voy a preguntar ya ahorita por qué. Algunas personas pueden decir sí y tener la razón, pero ojo, otras personas pueden decir no y también tener la razón. Esta pregunta puede tener múltiples respuestas. Depende de cómo se analice. Elija una posición, por favor. ¿Qué piensa? Y escríbame en el chat. Sí, está de acuerdo. O no, no está de acuerdo. ¿Nadie más, Sara? ¿Solo 4 respuestas? Tefa, Luna, Nico, Isa Castaño. Daniel, write down your answer, brother, please. Cata Castro, write down your answer. Dani Díaz. Dani Ruiz. David Leonardo. Lizarazo, write down your answer, brother, please. Juan Esteban Patiño. Don't just copy from someone. Choose. Think about this question, please. And tell me yes or no. All right. Who else? Okay. All right. Beautiful. Now we have some answers. All right. Thank you, guys. All right. So let's go with the why, right? I want to know why, guys. I want to know why. So, Lunita.
Yes.
Lunita, why did you think that the scientists are correct? Why?
Because according to the table that is in the the questionnaire,
Okay.
in the 1920 to the 1930, the intensity of or the hurricane striking was 5, and then it increased through the years, and then they decrease. So
Uh-huh.
I think that the scientifics are correct because like I don't know how to explain that. That's so like
You can do it in Spanish, Lunita, if you want to.
es como, o sea, digamos, como que baja y sube. Y pues yo creo que debido a eso, o sea, como que se mantiene y después baja y vuelve a subir.
Ok,
Entonces,
ok. ¿Piensas que eso es lo que va a pasar, sí?
sí, que va a volver, después va a volver otra vez a subir y otra vez a bajar.
Ok, muy bien, listo, Lunita, muchas gracias. Ok, gracias, mi niña, perfecto, gracias. Vámonos con otra persona que nos diga por qué piensa que sí. A ver, aquí varias personas me escribieron que sí. A ver, vamos con Juan Esteban Patiño. Papá, ¿estás ahí?
Yes, mister.
Listo, papá, cuéntame. ¿Por qué piensas que sí están, que sí estás de acuerdo con los científicos? ¿Por qué sí estás de acuerdo con los científicos?
Pues porque es que, digamos, de acuerdo a cómo venía el comportamiento de la gráfica, pues se puede predecir eso.
Ok. Ok, listo. Bueno, gracias, papá. Ok. ¿Alguien piensa que no? ¿Ninguno? Ok, pues yo pienso que no. Yo pienso que los científicos no tienen razón. Recuerden, yo les dije, esta pregunta puede tener múltiples respuestas. ¿Y por
Pero
qué
¿cuál
lo
es la
pienso?
razón, profe?
Dime, papá, dime. Ah, el por qué. Ok, ahí va. Gracias, Nico. Ahí va. Pues bueno, si vemos la gráfica, mira, parece que sube, ¿cierto? Y luego baja. Tiene sentido y luego vuelve y sube. Pero en términos de predecir, si yo miro, esto es una década, ¿cierto? Esto es del 2000 al 2010, ¿cierto que sí? Y si miro la siguiente, o sea, 2010 a 2020, es mucho más arriba, tanto que se sale de la pantalla. De hecho, si yo cambio el window y miro un valor en Y más grande, por ejemplo, en Y, para que la pantalla quede más grande, listo, voy a hacer que la pantalla quede más grande. Poner, por ejemplo, 200. La pantalla queda re grande, la gráfica. Coge, sube, listo. Luego vuelve y baja, ¿cierto que sí? Y luego vuelve y sube. Bueno, elegí un valor muy feo entonces. A ver, vamos a cambiar window otra vez. Pensé que subiría mucho. Vamos a poner aquí, no sé, 50 entonces. Mejor. Sube, ¿cierto? Parece que está fluctuando, ¿no? Pero luego parece que sigue subiendo. Si yo quisiese ver el comportamiento de esto en X, no sé, una tercera década, por ejemplo, del 2020 al 2030, cambio en X, pongamos en X un valor más grande, por ejemplo, hasta 15. ¿Cómo quedará la gráfica entonces? Mira, sube, baja, sube, y ahora se supone que tiene que volver a bajar, pero parece que no está bajando. Esa es la idea de fluctuación, ¿cierto? Sube, baja, sube, baja. No, pues no bajó. Ok, de acuerdo a nuestros resultados, o sea, nuestro modelo dice que en realidad esto no fluctúa. Los científicos dicen que no, mira, some scientists believe this is just a natural fluctuation that could last another decade or two. For what I can see, this is not a fluctuation, and it looks like this continues to infinity. This is not gonna last for 1 or 2 decades. This is gonna continue for infinity. Eventually, the United States is gonna have so many hurricanes that they're just gonna destroy the country. Look, in this decade, they're gonna be around what, 50 hurricanes a year? But that's a lot of hurricanes, right? So again, according to our data, according to our results, I would say no. The scientists are not correct. But again, if I just look at it without having to expand this so much, I would also say that I think this will continue to go up and then continue to go down as well. If we had more data, then we could predict this a little bit better. Even furthermore, look, we just did a cubic regression, but cubic functions only have 2 fluctuations. If we did a quartic, if we did a quartic regression, quartic regressions have 3 fluctuations. Maybe that would happen then. Maybe we could see something like this going up and then going down. It depends on the model, right? That's what I say, that this question, the final one, can have multiple answers. And each of those are correct. All right, guys. All right, beautiful. Look, hopefully I teach you something new today. Hopefully I teach you to analyze this type of questions, right? And actually give it some thought. All right, let's go for question 4. Question number 4. All right. I'm going to read this one because I want you to see that this is exactly like question number 3. Look, the following data represent the cost of manufacturing Chevy Cobalts. Chevy Cobalts are these ones, these cars, right? Chevy Cobalts are the marks of these cars, all right? And the number of cars produced. So X is the number of cars, so we can produce 0 cars. That costs 10,000. Remember, the cost is in thousands of dollars. So producing 0 cars costs $10,000. Producing just 1 car is going to cost $23,000. Producing 2 cars, $31,000, and so on, right? Beautiful. Let's go with question A. Use a graphing utility to draw a scatter diagram. All right. That is the same as question 3, right? B. Find the cubic function. Right, this is modeling. Same as question 3, right? The C. Predict. All right, same as question 3. So what I want you to do, guys, please, go ahead and write the answers. Do all of this process. You guys are going to do these questions yourself. I'm not going to help you, all right? Do these questions yourself. Write the answers in the notebook. and then we will compare. I'm gonna do the same, and we will compare to see if we got the same answers, all right? Again, I'm gonna pick one of you to tell me the answers to each of these. So, I'm gonna mute myself, and we'll meet in what? 10 minutes? I think 10 minutes is enough, right? 10 minutes. We'll meet again in 10 minutes, guys. All right, guys. I am back. Did you finish the exercise? If you don't say something, I'm going to assume you guys did.
Teacher, is that I having some problems
Okay,
with my
continue.
calculator, but I am fixing it.
Mister, you can repeat how we can do the store
The
regression.
regression, sure. Look, go to statistics. Right? So here. Press statistic, right? Go to the left, calculate.
But to
What?
store it. To store it. O sea, cuando ya uno le da qubit regression, ahí dice store, ¿cierto?
Ajá.
No me acuerdo cómo es que hay
Okay,
que
look.
ahí.
So qubit regression right here. Down where it says store. Here, press the bars bottom. There. move to the right to y variables, to the right, y variables, and choose the function one. From there, it's gonna give you the y, the functions, right? Which one of these variables, y? You press the first or the second one, whatever. In this case, I choose the first. So I did the same first, and then calculate. I'm not gonna show you because I don't want you to see my answers. Is that okay, Patiño?
Yes, Mr.
Beautiful.
Thanks.
All right. I think Nata Quintero. Nata.
Yes.
Hi, Nata. Because you did it already, I am thinking, can you show us, please, your graph?
Yes, I turned the camera on, but I don't know if it is.
It's not on right now. It's off.
Es que a mi computadora unas veces como que se le cae la cámara, no sé por qué.
Tan raro. O sea, ¿te dice en este momento que tu cámara está funcionando?
Sí.
¿En serio? A ver,
Sí.
¿y si la apagas y luego la vuelves y la prendes?
Ok.
Y con el botoncito de activar y volver a activar cámara.
Ahí ya me dice que ya.
Pues no. Tan chistoso esto, ¿verdad? Ok, bueno, Nata, pues no se pudo. Hoy no pudiste usar la cámara. Pues, ¿qué más, no? Bueno, gracias, Nata.
Nada.
Yo sé que tú querías mostrarnos igual. Gracias, Nata. Another one. Dani Díaz. Dani. Dani Díaz. Dani. Dani, you here? Say something or write something in the chat. Show me that you're here, Dani. Dani. Dani a la una. Tengo que ponerte ausente, Dani. Dani a las dos. Dani, por favor, no quiero ponerte ausente, no. Dani,
Aquí.
¿por qué no estabas?
Ah, no, es que no, una cosa que mi mamá pide, pero pues ya.
Ok. Dani, muéstranos la cámara y muéstranos porfa tu gráfica.
Gráfica. Ah, bueno, pues la tengo en la calculadora, todavía no la he puesto, no la he dibujado, no pasa nada. Ups.
Ah,
Ay, no.
pues sí, eso es lo que estamos haciendo, Dani.
Ay, pero
Ok, perfecto. Muy bien,
Mírala.
Dani, perfecto, mi niña. Excelente. Te quedó igualita a mí. Gracias, Dani.
Ok.
All right, guys. I'm going to show you my results and you tell me if you got the same or not. All right? You ready? Give me just 1 second. All right. This is what I got. Look at that. This is what I got. The points are the data, right? And the function is almost perfect. Look at that. It's so beautiful. It passes through most of the points. Look at that. Looks like it is a really, really good function, right? A really good model. All right. Beautiful. If you got something like this, then you probably got it correctly. All right. This is question A and question B, right? We did the scatter plot diagram, and we also found the function. All right. Let's jump to C. Use the function to predict the cost. Ooh. Before I do this, anybody in the chat want to say what is the amount of dollars of creating 11 cars? Anybody in the chat? Nobody?
Estefanía ya lo escribió, profe.
Ay, no. Ay, sí, ok, no veía. Ok. Thank you, Tefa. Okay, Tefa, you're missing something, right? 170.8 what? Almost, not quite, almost, something more. Go ahead and read the question. Look at this. In thousands of dollars. So it's $170.8 thousand dollars. Right? It'll be
Okay.
two.
Yeah, is that I really write a lot slower than many people, so that's why I didn't write it.
Okay, good, Tefa. Thank you. All right, so let's see. In case you didn't know how to do that, to predict second trace, right? That is gonna give you the calculate menu, and you select the value option. Here, from value, you press 11. Why 11? Well, because we wanna predict the cost of creating, manufacturing 11 cars, these cars, the cobalts. All right, enter, and after a while, we will have the solution. 170.8 round to 1 decimal, right? 79 round to 2 decimals. Or we can round, depending on the amount you want to
Teacher,
round.
I got a problem.
Danny, tell me.
When I say to calculate the value of 11, it tell me it has an error.
Sure, Danny. Why? Simple. Because your window is not enough, is not big enough to show the value you want to calculate. Danny, look. In here,
Okay.
I am
Okay.
showing the value for X. The value 11 can be seen right there, right? This is 11. And this, the value 170 can be seen. So you need to increase the window, increase the window, yeah, the values for the window, to accommodate the X and the Y values, all right? Look, these are my window. I have it from -1 to 12 with a scale of 1. That is for X. And in Y, I have it from 0 to 200 with a scale of 5. So every single line that you see there are 5 values on a scale of 5. Why a scale of 5? Well, because I wanted to do it, right? I wanted to change the scale. You can do the scale that you want. And if you graph, this is the result. All right. Cool. Let's continue with the last question. Interpret the y-intercept. What is the y-intercept? Paso un momentico aquí al español porque aquí se me pierde gente. Mira, aquí se alcanza a ver. Ojalá me estén siguiendo, listo. Ojalá ya no estén pegados a la calculadora. Ojalá me estén viendo. Esta es nuestro eje Y, ¿cierto? Y aquí está la función, la azulita. Ok, pues mira que aquí se alcanza a ver cuál es el intercepto con el eje Y, ¿cierto? Eso es cuando construimos 0 carros. Cuando construimos 0 carros, aún hay un costo. Uno pensaría, espera tantico, si no estoy construyendo carros, ¿por qué me va a costar algo de plata? No tiene sentido. ¿Cierto? Mira, aquí se ve en la tabla. 0 carros producidos. Mira, esta es la tabla, ¿no? Number of cobalts. 0. No producimos carros. No creamos carros. Pero aún así el costo son $10,000. Esto está en miles de dólares, ¿no? Aún así el costo son $10,000. Interpretar el intercepto con el eje Y, es decir, ¿por qué está pasando esto? ¿Por qué a pesar de que no se construyen carros, aún hay que pagar algo? ¿Por qué? ¿Alguien tiene una idea, mis niños? En el chat, por favor. Si tienes una idea, la escribes en el chat. En este curso hay personas con ideas muy, muy, muy interesantes. Me gustaría saber qué piensan. Ok, Sebas dice, por los materiales del carro. Papá, creo que vas en la dirección correcta, pero usaste la palabra que no era. Materiales del carro, pero ¿cuáles materiales? Y mira que no estamos construyendo ninguno. El costo de construir un carro, pues es el costo de comprar los materiales, ¿no? Pero no estamos construyendo ningún carro. Entonces, ¿qué está pasando? ¿Qué puede haber ahí? Si no son los materiales, ¿qué es? Juan Nicolás Parra, puede ser por el pago de salario. Este tipo le pegó pago de salarios o por los costos de mantenimiento de la fábrica. Nico Parra. Muy bien, mi viejo. Nico Parra salvando a la patria. Muy bien, papá. Los costos de los empleados. Esto no se construye solo. Esto hay gente que hay que construir, ¿no? ¿No? Y si van a la fábrica, igual no construyeron nada, pero igual tienen que pagarles, ¿cierto? O de pronto hay que pagarle al señor que cuida que nadie se meta, ¿no? Al celador al guardia, ¿cierto? Al señor hay que pagarle, aunque no se construyan carros, al señor hay que pagarle. O de pronto a la gente que hace el aseo, no sé si tienen de pronto restaurante en esta empresa, también hay que pagarle a la gente que hace el restaurante, ¿no? A la gente que hace la comida, a pesar de que no se construyan. No solo eso, sino que las máquinas requieren mantenimiento, ¿no? Estos son maquinitas, de pronto máquinas que cortan acero o doblan acero o comprimen, no sé, las llantas, etcétera. No son costos de materiales del carro, porque no gastamos nada del carro, pero sí las maquinitas hay que construirlas. Y no es solo eso. Di tú que esta es una empresa que esté pagando arriendo del local. Ah, ahí están los $10,000. Todo eso es el costo de la empresa sin el costo de producción de carros. Eso significa interpretar el Y-intercept. Mirar por qué, a pesar de que no se construye en X, por qué de todas maneras hay un costo. Porque eso es interpretar el intercepto. Dani, digo, Nico, perfecto, papá. Espectacular tu análisis, mi hermano. Muy bien. Yo sabía que había gente con ideas espectaculares. Yo sabía que alguien iba a pegar con esa idea. Muy bien. Para los demás que pensaron en esto, pero no lo escribieron, no tengan miedo, muchachos. Escríbanlo. Escríbanlo, muchachos. Ok. That is the end of our fourth question. Look at this. 2 questions regarding modeling. That gives you an idea. That should give you an idea of what is the question, the exam going to be about, right? All right. That is going to give you an idea of what the exam is going to be about. If I am making 2 questions about modeling, look, we made just 1 question about polar coordinates and just 1 question about complex numbers. But these, we have 2 about these. Huh? Is the teacher going to ask about modeling? Oh, man, I don't know. I don't know about that. All right, let's go for question 6. And it looks like we might be able to finish the full questionnaire today. All right, guys, go ahead and read question 5, please. And as usual, I'm going to ask one of you to please explain us what is the question about. All right, I think that's enough time for reading the question. Let's go with who am I gonna ask now? Who am I gonna ask now? All right, Nico got a good answer already. Patiño's asking. Carol maybe. Danny, you want to?
To solve A, yes.
All right, Danny, let's do something. Before you answer A, go ahead and explain us what is the question about. All right, Danny?
Okay, as the problem say, in physics, it is established that the acceleration to gravity in meters per second minus 2 at the heights meters above the sea level is given by that equation that you're seeing. GH is equal to 3.
Whatever, we got the equation, right? Whatever, that equation, right?
Yes.
Okay.
And they told us that 6.374 per 10 to 6 is the radius of Earth in meters.
Okay.
So the first sub question is asking us, what is the acceleration due to gravity at the sea level?
Okay, brother. How would you do this, Danny?
Well, first I have to find what is the sea level. It is 0.
Uh-huh.
So in this case, for solving question A, H will be 0.
So the answer of A is 0?
No. That's one thing that we have to know to answer question A.
Okay, beautiful.
H will be 0, not the
Okay,
answer.
so instead of H, you write down a 0. All right, Danny, beautiful. Okay, and what does that give you as a result? Okay, I'm assuming you're doing it in the calculator, right?
I'm doing it. I'm writing in the notebook and plotting the calculator. Just
beautiful. Thank you.
Wait a minute.
Take your time.
Wait a
Take your
minute.
time, Danny. Let me show you to this presentation, maybe, and instead of this. There, beautiful. Uh-huh. All right. This presentation is better now, right? Okay, so this was, let me just erase this question. This was a question from the previous exercise. All right, we're doing 5 now, right? We're doing question 5 now. All right, just like Danny said, in question A, the sea level is 0, right? So H equals 0. What we need to do right now, what we need to do is replace in the formula, that formula you guys can see there. This is hard. There. This is hard. What you need to do is replace H by 0. Now, be careful where you replace it. Be careful how you write it in the calculator. And tell me, what is the acceleration due to gravity then? If you got the answer, go ahead and write it down, and go ahead and write it down in the chat, please, if you have the answer. All right, 4 people already. Thank you, guys. All right. You're saying the answer is 9.82. And you will be correct, but you are missing one really important thing. What is it that you're missing, guys? The value is okay. The number is correct. But the answer is not. Because you need to write down something extremely important. What is it? No idea? All right, look at that. Nico got it. Nata got it. Tefa Cabrera got it. All right. You're missing the units. You need to write down the units, guys. Look, the units are right here. We can see it right there. in meters over second square. We have it right there, meters over second square. So we're going to write them down. Meters over seconds to the second power, second square. This is a square, right? I don't know if you guys can see it or not, but let me do it bigger. There, square. Meters over second square. All right. Okay, cool. Beautiful, guys. Beautiful. Beautiful. Perfect answer. Let's go with question B. All right. I'm going to read this one myself. And let's see who gets the answer. The Willis Tower in Chicago, Illinois. All right. So someplace, Willis Tower in Chicago, Illinois, is 443 meters tall. All right. So what is the acceleration due to gravity at the top of Willis Tower? All right. So for question B, we are given some information. We are given that Willis Tower is 443 meters tall. Well, this is going to be the value h again, because that is the tallness, the height that we need to replace in our gravity function, right? In our gravity equation. Look, in this case, the sea level was 0. No elevation at all. No elevation at all. But in this case, we have some height, some elevation. We whack this in the calculator and you tell me the answer, please. If you got it in the chat. No, I'm sorry. If you got it, put it in the chat. Answer. Don't forget the units. Don't forget the units this time. All right. Give it a couple of tries and you guys can tell me. Okay, you guys are writing something, but looks like it's the same answer. You guys for sure? 9.
It's that it is 9.81, but next to the 1 is a 1. It's a 9, sorry.
All right, so let's do
it
that.
is rounded.
9.81. 9.
And there's a 9.
And what after the 9?
A 4.
Okay, so let's leave it like this. This is a correct rounding. Right? Let's leave it like this. Right? Let's leave it like this. And what about the previous answer? What if we leave it? What if we leave 3 decimals here to try to change, show the difference?
It is
right?
that next to the 2 is a 0 in the first answer.
Okay. All right. So let's just write this down then. A 0. It doesn't really matter, right? It doesn't really matter.
Oh wait, but next to the 0 is an 8, so it will be 1.
So a 1.
Teacher.
Yes, Danny.
I think I know the reason of why the answer is basically the same.
Why, Danny?
Because the gravity in the air will always be 9.82.
Well, according to this graph, according to this function, it's not the same, right? Okay, to 1 decimal, it is the same. Look. So what I'm thinking is the difference between gravities is so incredibly small that is almost nothing, right? But look, we clearly have a difference. 821 and 819. We have a difference of 3 milli. I don't know what is this. Millisum, right? In the 3rd decimal. That is almost nothing. It's so incredibly small, the difference, that even at level 0, right? So at no elevation, and something really high, 400 meters, that is incredibly high. We kind of have the same gravity. All right, cool. I find it cool, right? I find it cool. All right. Let's go with question C. The peak of Mount Everest is at, wow, 8,848 meters. Wow. What is the acceleration due to gravity? Guys, go ahead and help me out with that one, please. I'm going to write it down here. C. We know that now the value h will be 8,800. 48 meters. Look at that. 48. All right. What is the answer, please? $9.8 what? maybe more decimals? Maybe more than 2 decimals? A third decimal? Maybe?
That is 9.79.
79 what, Tifa?
4.
4. All right. Let's leave it like that then. All right. Thank you to Danny, Tefa, Majo, and Danny Reese. All right, thank you guys. Of course, don't forget about the units. You guys didn't forget the units. I'm not gonna forget the units either. Meters over second square. All right. Now let's analyze this because Danny was into something really good. Danny Osorio. Danny was into something really good. Look, Danny said, teacher, isn't the gravity always the same? The gravity is always the same. Come on. We are on Earth, right? So on Earth, gravity is a constant, right? Well, it looks like the differences between each gravity, look, 0 elevation, 400 meters elevation, and 8,000 meters elevation. The elevation in height is really, really significant. But the changes in gravity are not significant. Look, 9.8, 9.8. And if I were to round these to 2 decimals, to 1 decimal, sorry, this is 9.8 as well. Look at that. 9.8, 9.8, 9.8 as well. If I were to round this. I haven't rounded, but if I were to round it. So we can kind of see that the differences are minimum. So incredibly small that we can say that gravity is always the same. At least on Earth, right? At least on Earth. Look at that, guys. All right. Beautiful. All right, that was the question number 5. I just wanted to show you something with this, all right? I just wanted to show you this and how to replace in the calculator and do a cool analysis, all right? The idea behind this question was that you guys get to jump into these types of analysis. All right, cool. All right. Good question, good question. All right, let's jump into question number 6. As usual, you guys give it a read. And I'm going to ask one of you to explain us what is the question about. After that, we will finish our questionnaire. All right, let's see. All right. Okay. And that question is absolutely simple, right?
Teacher, a question.
Daniel?
And in the question, the value N are the light or the panels?
Let's see. Look at this. Let me change to something bigger. This. Let me see. Danny, look at this. Here is where the N appears, all right? Look at this.
Yes, it's the panels. It's
the panel, right? Okay, cool.
Yes, thank you, teacher.
You're welcome. Although I didn't do anything, right? You did it. But okay.
But at least you put the whole screen so I could get noticed.
Okay.
Thank you.
All right, let's hear it from Mari. Are you back? Mari Sainz? Mariana Alejandra Sainz, are you here? Are you back? Did you manage to get the meeting working or not? Right, looks like she's not here. Okay, another person then. I want to hear from one of the Samuels because we have 3. Samuel Bocanegra. Ooh, brother, are you here? Samuel Bocanegra.
Hi, mister.
Hi, Samuel. How you doing? You good?
More or less because my internet is not too well.
Ah, no. Ah, qué feo. All right, Samuel. All right, let's do this. Let's do this as fast as possible because maybe you just, I don't know, maybe the internet fails and you leave the meeting, right? All right. Samuel, go ahead and help us with this, brother. Can you tell us what is the question 6 about?
I read or what?
No, you try to explain it. You read it already, right? You already read it. So you try to explain it, please.
I don't know how to explain.
You can do it in Spanish if you want to. However you feel comfortable, brother.
Pues no sé, como que cuánto porcentaje de luz pasa a través cuando hay un espejo, cuando hay un objeto, ¿cómo se llama? Un vidrio.
Ajá. Muy bien.
Pues, y pues dar la función, no sé.
Ok, cool. Samuel, pero lo hiciste muy bien. Ay, no sé cómo explicar. Y ahí está. Muy bien, papá. Lo hiciste muy bien. Perfecto, Samuel. Ok, ahora cuéntanos. ¿Cómo lo resolverías? El A.
No sé.
¿Cero ni idea?
No, no, señor.
It's really
Okay.
simple to learn how to solve it.
Danny, but you already said this the previous one. Let's give
Okay.
somebody else a try, all right? Samuel, thank you, brother. Thank you. All right, let's give somebody else a try. I don't know. Do you anybody? Let's leave this as an open question. I want to hear from somebody to please explain us. Not just write down the answer. No. I want to hear how do you do it. So, for example, we have Valerie. Valerie already said something. Valerie, can you explain us how, please? Valerie.
Using the equation they give us.
Okay, but how? How did you solve the equation? What did you do?
You replace the n with the number of bands.
All right. Thank you, then. Thank you, Valerie. Appreciate it. Thank you, Valerie. All right, so yes, that is exactly what we're going to do. Look, the question says that the amount of successive bands that we have is given by n, right? And then the question is asking us for the percentage of light passing through 10 panes. Whatever. 10 thingies, right? So what we do is replace n by 10. Put it in a calculator and get the real result. All right. I'm going to write this down in the board just for the people who are at home reading these or watching these videos after the class. Because I think everybody got it already from the chat, right? All right. Answers here. Question 6, right? Again, the function is P of n, right? Equals 100 times 0.97 elevated to the n, right? Now, in question A, we are given that n has to be 10. We have 10 panes, right? From here, all we do is replace 10 in the end. So the percentage on 10 panes are going to be pans. I don't know, guys. Sorry. It's going to be 100 times 0.97 to the 10. If we put this in the calculator, we get exactly 73.74. Is it like this? Or what? No, 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 no. No, señor, no. Estamos haciendo algo mal. ¿Alguien se da cuenta del error, no? De pronto alguien usa un error. Es una cosa mínima. Súper importante, pero hay un error. Aquí hay un error. En el análisis que hemos hecho hay un error. En la
Teacher,
matemática tal vez no.
The
¿Cómo,
values. The values.
Las unidades, no.
No,
Los
the
valores
value.
¿Este no es el valor que es? No entiendo.
Percentage. The percentage is missing.
Ah, el porcentaje. Ok, listo. Entonces, espera, lo anoto. Ok, bueno, esa no era la respuesta, ¿no? Ese no es el error. El error es otro, Mueche. ¿No, nadie? Nadie, ok, bueno. Voy a preguntar algo para que me guíen, porfa, ¿listo? Ustedes metieron esto en la calculadora y les dio la respuesta 73.74, ¿cierto? Y luego ustedes pusieron el porcentaje. ¿Cierto que fue así o no? ¿Cómo les dio? ¿Alguno?
Todo eso, bro.
¿Tal cual? Ok, listo, gracias, Nico. Ok,
Sí, profe, sí, eso es lo que estás diciendo.
perfecto, Nico, gracias. Pero esta no es la respuesta. Esto es el resultado de la calculadora. Muy bien. Sí. Pero no es la respuesta. ¿Por qué? Ah, espera. Ah, no, mentira, está re bien. No, mentiras, yo estoy re mal. Está re bien. Lo reí re mal. Ah, qué triste. Ahora parezco tonto, lo siento. ¡Ah! No. No, mira, es que ya he leído que la función muestra la cantidad de luz que se daña. ¿Sí? La cantidad de luz que se dispersa al pasar por un panel o pues un pedazo de vidrio. Lo que significaría que hay que hacer la resta menos 100%, ¿no? Sería como 27% de luz es la que pasa. Pero no, lo leí mal. La fórmula dice la cantidad de luz que pasa y esa es la que nos están preguntando. Ok, este ejercicio estuvo bastante fácil, ¿no? Ok, ok. Ustedes tenían razón. Yo estaba mal. Qué feo. Ok. Question B. In this case, we know n is going to be equal to 25, right? 25? Uh-huh. So we have 25 thingies, 25 pans, paints, glasses, whatever, right? So how much is this? All right, we just replaced n by 25. So we have 100 times 0.97 elevated to the 25th power. How much is this, guys? Please let me know in the chat. Somebody said it already, but I'm missing the answers. All right, 46.70. And you guys did the percentage sign. All right. Okay, cool, guys. Thank you. 73.74% in the first one and 46.70% in the second one. All right, so what it looks like is that the more pans I put consecutively, the less light is going to show up, right? That's what it looks like, right? That is what it looks like. All right, guys, can we have a minimum? What is the minimum amount of light that will pass?
3%.
3. The minimum amount of light that will appear will be 3%. 3%. The minimum. Well, no, right? The minimum amount of light will be achieved when we put an incredibly amount of panes after each other. So maybe 10,000 panes. That is the minimum. What is the minimum? To do that, all you have to do is write, instead of n, write the amount, a really big amount, 1,000, 10,000, 1,000,000. Put it in the calculator and you tell me. Is there a minimum? All right. We're going to leave that as a homework, maybe, in case you want to practice, right? Okay, guys, that was the 6th question for today. What is this? Yeah, we don't have any more questions. I leave this pretty simple, right? These 2 questions were absolutely simple. But the important thing I want you to guys remember, Tefa, you are correct. 0, that is the minimum. The minimum doesn't exist. Eventually, if you put a big amount of paints or pans after each other, you will have 0 light coming through. It will be entirely black. That's the minimum. The minimum doesn't exist. Thank you, Tefa. You are correct. Did you do the exercise? Did you change n by a big number?
Yes.
Thank you, Tefa. All right. Well, somebody likes math. Cool, Tefa. All right. So in case you are thinking, but teacher, how is this questionnaire going to help us for the exam? Well, if you look at this, in 6 simple questions, we went through every single topic for this 2nd term. We didn't really study a lot, to be honest. Look at that. We didn't really study a lot, right? This term we saw a couple of things. We didn't saw a lot of things. We saw a couple of things, right? A couple of topics. All right. If you want to practice something to maybe get ready for the exam, what you need to do is do more exercises, right? Just go to the book, right? Grab the book and do more exercises. In fact, that is exactly what we're going to do right now. I'm going to cut the video here, and we will continue practicing just in case any of these questions will appear in the exam. All right. That's it, guys, for the class, or no, for the video.